Hey guys, it's Rising Edge Diagnostics here. I've got a 2005 Ford F150 with the 5.4 liter Triton. Customer brought it in, said it's running rough, and he believes it to be misfiring, which I did confirm. This thing has very low power. At first I thought, well, maybe there's a plugged cat. Was going to do a back pressure test, but I noticed that the cats had already been replaced. So instead of doing a back pressure test, I decided to go in cylinder. When I went to go pull the spark plug, I noticed that they have been replaced as well. So we have the parts cannon launched at this truck. Didn't fix it. Surprisingly, the customer, whoever was working on it, did not replace an injector or a coil. I went ahead and swapped the coil to another cylinder. That didn't change anything. Scoped the injectors. They were all good. Scanned for codes, obviously, before I did anything. Found several misfire codes for bank 2, as well as camshaft position performance codes for bank 2. Did a visual inspection of the sensor and wiring. Didn't find anything crazy. Unfortunately, the VVT data on this was locked at 0. It would not change. I assume because there's a DTC for VVT problems, so I guess the monitor just doesn't run. Normally I would be able to see that, but for whatever reason it wasn't showing anything. So I decided to go in cylinder, get some practice, So here we are. This is my bank 2 in cylinder for cylinder 5, which this one was counting up the most misfires. 5 and 7 were actually counting up misfires consistently. This waveform over here is actually bank 1. This is in cylinder 1. And you could tell right away there's huge differences in both waveforms. Let me get my pen. You can see here we have what you would typically see an exhaust pocket. Over here we have no exhaust pocket. What does that mean? Well, to me, that means that the timing is off. And you can see here, I've marked out my 720 degrees in 30-degree increments. Then I overlaid 10 degrees on that. I wanted to get as accurate as I could, or at least close to it. Now, the valve timing events go exhaust valve opening at 50 degrees before bottom dead center, exhaust valve closing at 20 degrees after top dead center, the intake valve opens 15 degrees before top dead center, and the intake valve closes at 30 degrees after bottom dead center. So if we use that, we can see that right here, the intake valve is closing early. Now it should be closing over here. We can tell that because as the piston comes back down to bottom dead center, we see a little bit of a vacuum trough here. Now you really shouldn't see that because the intake valve should still be open up until this point. But because it's closed and the piston's traveling down, it's actually drawing vacuum in the cylinder. You can see over here that the intake valve is closing when it should. And then as the piston comes up, we build pressure in the cylinder. This is a cranking test, so you're not going to see a whole lot of pumping characteristics. At least, maybe not with my homemade transducer. Maybe on a WPS you might, but this is what I built for my own personal use, and it seems to be working so far. I can tell what I need to see from the transducer I built. Now, this early exhaust valve closing What does that mean? Well, on these engines, if you know anything about the 5.4 Triton, they like to stretch chains, they like to break guides, jump teeth, the phasers go bad, what have you. I've also seen cam failure as far as grinding them down. I've also seen valve springs break. It's a myriad of problems on these trucks. This one, I'm pretty confident that there's a timing issue. You know, compared bank to bank, definitely a problem.